For our next example, we're going to do the same thing. We're just going to do favorable over total, but this time we have to figure out how many favorable responses we're going to have. Computer generates 5-character password, 2 letters followed by 3 digits. All passwords are equally likely. So what ends up happening is I've got 2 letters and then one, there's going to be a 4 somewhere in there. So maybe I'll have a U and a D followed by a 4, a 5, and a 1. But there's guaranteed to be one 4, just one 4. So I might have a U and a D and a 9 and a 4 and a 1, and the 4 goes in that second digit. Or maybe I have a E and an R, and then I end up with a 5, 5, and a 4, something like that, so that the 4 ends up in that last digit place. So the 4 is going to end up somewhere. Well, I can use any letter I want. So the first letter can be 26 different letters. The second letter could also be 26 different letters. We can repeat them. They didn't say we couldn't. And then let's say that the first letter is going to be this 4. So there's only one 4, or the first number is going to be the 4. So there's only one 4. So we're going to put a 1 in there. Now I can't use the 4 for the other ones because I'm only allowed to have one 4. So there's going to be 9 digits in here and 9 digits in here. So I have 26 letters, 1 4, and then there's 9 numbers that can go in here and 9 numbers that can go in here because I used the 4 in that first digit spot. So if we do the math on that, we can do that here in just a little bit, but that's just one scenario. We also have to do the next scenario where we do 26 times 26 times the 9 numbers that aren't a 4, and then we put the 4 in the middle. And then we put 9 numbers that aren't the 4 on the end, and we do that math as well. And then we would have to do 26 times 26 times 9 times 9, and we will put the 4 on the end so that that 4 is represented in the third spot. So now I've got the 4 in the first spot, 4 in the second spot, 4 in the third spot, and all these outcomes are equally likely. So if we do the math on that, we find out that the 26 times 26 times 1 times 9 is 54,756, really, really close to 55. It's almost like somebody planned that. But we're going to take that number and we're going to add it 3 different times, because when we do this math, we'll get the same math every single time. It'll be 54,756 for each one of these scenarios. So if I add all 3 of those together, I get 164,268. So this ends up being 54,756, and so does this one, and so does this one. And all of those outcomes are equally likely. There's an exactly 1 4 in the first spot, and the second spot, or the third spot. So what I have to do is add those together. And if I'm not mistaken, we ended up with 164,268. 164,268. Now that's our favorable amount. So what we want to do is take that favorable and divide it by the total. On the last problem, we found out the total was going to be 676,000 was our total, and we're going to do 164,268 divided by that 676,000. We already did that on our calculator, and we got 0.243. Lost it. Almost got it back. There we go. So 0.243 is our probability. This is 24.3%, but I like the 0.243 better for your answer. I did have a student the other day that was asking Mr. Studer, they said, is there any way you can show us the math on your calculator? Can you include that in your notes? You've got all these notes over here, and you're not showing us how you typed it in. But with these newfangled handy dandy calculators, I can. So I can grab it, I can bring it over here, and I can drop it in, and all those pretty numbers show up. And so from now on, I'll include what math I used in the slide. So when you go look at the finished product, it'll have that fun in there. Okay, I think we have 2 more videos to go, and that'll be this section. So hopefully these videos aren't too long and they're not bothering you too much, none. But anyway, I hope all is well back there at Corona break. You guys are enjoying your time, and we'll see you in just a little bit. Good time.